Now, this one doesn't look like a Bernoulli equation, but if we do some simplification, so we first do dr over d theta. We break the fraction, r square over theta square plus 2r theta over theta square. And now this is equal to r square over theta square plus 2r over theta. So remember, normally we have dy over dx, and then we want plus y times a function of x. So here r is playing the role of y. So this is the one that has the single r in it. So that needs to be on the left side. So we'll have dr over d theta minus 2r over theta is equal to r square over theta square. And here, to put it in the form where we have plus y times or plus r times, so it'll be negative 2 over theta. And then remember, on the right side you have y power n times q of x, which in this case will be q of theta. So we'll write it as 1 over theta squared, so that will be the q of theta, and you will have r power 2, which is like y power 2. So this is Bernoulli. So in this case you have p of theta is equal to negative 2 over theta. Q of theta is equal to 1 over theta square, and n is equal to 2. So our substitution will be v is equal to, so it's y power n minus 2, so in y in this case is r, y power 1 minus n, so in this case it will be r power 1 minus n is equal to r power 1 minus 2 is equal to r power negative 1. So after this substitution, we know that the equation becomes 1 over 1 minus n so it will be dv over dx, which in this case will be dv over d theta, plus v times p theta is equal to q theta. So 1 over 1 minus 2 dv over d theta plus v times, so p of theta will be negative 2 over theta is equal to q of theta. This is 1 over theta square. Okay, I'm trying to go to the next page. So let's just copy, remember this, what's going on. So 1 over 1 minus 2 is negative 1. So this is -1. So to get dv over d theta without any coefficient, multiply everything by -1. So we will get dv over d theta. This will become a plus 2v over theta is equal to 1 over theta square. dv over d theta plus 2v over theta is equal to, so we are multiplying everything with -1. So this becomes positive, this becomes positive 2v over theta, and this will become negative, -1 over theta square. Now this is linear. Integrating factor is equal to e power. So this is like v is like the y. So whatever comes with it is coming in this integral. E power integral of will be 2 over theta. D theta is equal to e power 2 ln theta is equal to, so you raise this 2 in the power of theta. So then the e and ln cancel out. So it's theta squared. And then the solution is y is equal to, so y is v in this case, v is equal to 1 over I, so 1 over theta square, integral of the theta square, integral of I times the right hand side, and right hand side is -1 over theta square. D theta plus c, and this is all of this. So then these two cancel out, and the integral of -1 is just negative theta. Negative theta plus c. And then remember v was theta power -1, I think. Let's go back. V was r power -1. So this is actually r power -1 is equal to actually 1 over r. Is equal to c minus theta over theta square. And they probably will want us to write it as a function of r. Let's see. Let's see which form they want. Okay, yeah, they want it as a function of r. So that means, so r to the -1 is 1 over r. So if you want to get r, you take a reciprocal of both sides. So r will be theta square over c minus theta. Let's see if they take it in this form. Theta square over c minus theta. Okay. And then question number 10, you can handle. It's very similar to what we have done. And that actually finishes this section and this chapter.